Hi, this is Mr. Max. So what I'm going to do here is graphs of functions, and I'm going to do the straight line graphs. So this work is also usable for grade 8 learners because they are going to do coordinates. Grade 9s, this is exactly the topic that you will be doing. And then also the grade 10 and 11 learners, when you do your graphs of functions, this is very much important work. And the grade 12s can use this as revision, both core as well as extended learners. So I'm doing the linear function as I said earlier, and it is in the form y equals to mx plus c. Now the m that we have is obviously the gradient, and the gradient is represented by the measure of how steep a particular line is. Alright, the gradient or the slope of a line tells us how steep it is, that value there. And that value can be a fraction, and we prefer it to be a fraction if it is, and also can be written as a decimal, doesn't matter, but you have to be a bit careful. So what we are saying the gradient represents is the difference in two y values or the exchange in y value. So suppose we know what this particular y value is here for r. Okay, so let me say we bring in and we say that this y value here is 5, and we say this y value here is 1. So the difference here, the exchange in y or delta y as we say, will be 5 minus 1, which is obviously 4. Alright, then we do the same here. Suppose we know that this value here for x, let's say this value for x is 1, and let's suppose this value here for x is 6. And in order for us to find the exchange here, it's going to be 5. So the exchange here will be 6 minus 1, that is delta x. Alright, so the way we calculate the gradient is calculated by taking the exchange in y, or we say delta y, we divide that by the exchange in x, or we say delta x. In this particular case, it's going to be 4 units upwards and 5 units across, and therefore the gradient is 4 over 5, or 0.8. Now, we prefer to leave the answer like this, as I was saying, because that tells us the exchange in y divided by the exchange in x, and also sometimes people have to say the rise divided by the run. Okay, these are all very nice terminology that can help you to understand what we're dealing with. So when we are talking about the gradient, or when we're talking about the slope, we are talking about how steep a line is. And one of the things that we realize is that the bigger the value of m, the steeper the line. And also at a later point, you will see that that value can be negative as well, and can be positive, and it does something to that particular line. So if I was to bring in quickly here 2 points, and I bring a point here, and let's suppose this point here is the point 1 point, comma 2, this is point P. So it's 1 for the x and 2 for the y. And then let's suppose this particular point here is 5 for x and 4 for y. And we are supposed to calculate the gradient. So I just take the two exchange values, exchange in y. So I started with point r, and I will start with the y value of r, which is 4, minus 2. Now when you get 4 minus 2, obviously that gives you positive 2. And then I start with the x value there, because I started with the y value of the point. So I'm going to be 5 minus 1, which is 4. So the gradient of this line is a half. Alright, or if we switch the points around, you still get to the same point, the same gradient. Suppose I start from P to R, so the gradient of P to R, so I'll take 2 for y, subtract by 4, which gives you the negative 2. Then you take 1 minus 5, which gives you negative 4. And the negative divided by negative is positive, and can you see that the gradients of this particular line, the gradient is equal, it's the same, whether you started from R to P or P to R, as long as you don't switch the points around. Right, the other thing that comes in handy is what is referred to as the y-intercept, simply where the graph cuts the y-axis. Okay, that's all that the y-intercept has. So here I have got 3 points here on the y-axis. I have point 3 here. I have the origin 0. I have negative 2. So if I bring in this particular line, the blue one here, then the y-intercept of this line will be 3. So normally the y-intercept is represented by 3, and you will say c equals to 3, or the y-intercept is 3, when they ask you something like that in the exam. If we take the one here for the green one, the origin, here the y-intercept is 0. This is typically for equations like maybe you have got y equals to 3x. Okay, then there's nothing here, plus nothing, or y equals to minus x. Okay, because you can see that there's no value here, so that means that the y-intercept is 0. The one at negative 2 here, this is where the line cuts the gradient at negative 2. So what you see, you can actually see this particular value. You don't have to calculate it. Once the equation is written in gradient intercept form, you can be able to detect what the gradient is. You can also quite clearly see what is the y-intercept. Y-intercept, as I said, is where the line cuts the y-axis. Now let me bring in parallel lines. And what are parallel lines? Well, parallel lines are two lines that are always the same distance apart. Always the same distance apart. They never meet. Okay? So they will never ever meet. So the distances between them is the same and they will never meet. So what can we learn about the gradients of parallel lines? Let me take this light blue line here and I calculate the gradient of this line here, and I have done it. So when I calculate the gradient of line RP, I take the exchange in y. So obviously I started with 4 minus 1, then 2 minus 4. So I get the gradient is negative 3 over 2. So let me bring other 2 points on this line, and I refer to those points as maybe A and B. And I calculate the gradient of this line, this darker line. All right, and if I've done it here, I'll take, for example, the gradient 4 minus negative 2. So it's 4 minus negative 2. You must be very careful here. And then negative 2 minus 2. So I get that the gradient of line AB and the gradient of line RP, they are equal. So parallel lines, their gradients are equal. And this is very important that you understand that. The only thing that comes into play is where the lines are cutting the y-axis. So I can actually write the equation of this line here. It's going to be y equals to, all right, negative 3 over 2, all right, we just make that negative nicely there, x, and it cuts the y-intercept at 7 plus 7. That is what that equation is. And this particular one, this one here, the gradient will be, or the equation will be y equals to, same gradient, negative 3 halves or 1.5, all right, x, and it cuts the y-axis at 1. So the only difference between these lines is where they cut the y-axis or the y-intercepts. Otherwise, their gradients are particularly interesting. Their gradients are very much equal. The gradient here is negative 3.5, and the gradient of this one here is negative 3.5. So parallel lines, very important, their gradients are equal. Let's talk about perpendicular lines. And we know that they are saying here, a line is said to be perpendicular to another line if the two lines intersect at right angles. So that means where the two lines are meeting and that angle is 90 degrees, the two lines are perpendicular to each other. So what I've done here is I have a blue line here, which is y equals to negative 1 over 3x plus 2. And then I have a red line here where the gradient or the equation of the line is y equals to 3x minus 4. So if you take that negative 1 over 3 and you multiply it by 3, you will get that the product is negative 1. So what I'm saying is that if you are given two lines and you multiply their gradients and you get a product of negative 1, then that line and the other one with respect to each other, they are perpendicular. Like for example, the gradient of this line, which is 3, times negative 1 over 3 gives you negative 1. And what you need to realize is that whenever you do this, there has to be at least one negative sign. Okay, this is the only way you can get a negative answer. So suppose this line, for argument's sake, had a gradient of negative 3, then the other one should have been 1 over 3 positive. So let me bring in other two lines here for you to have a look at. So here I have the line y equals to negative 3 over 2x plus 3. The gradient is negative 3 halves. And here the gradient is 2 over 3x minus 2. Now if you have a look at the gradients, you will see that first of all the signs are different. And then you will also see that the numbers are reciprocals of each other. So that is 3 over 2 and that is 2 over 3. If you multiply them together, obviously you are going to end up with negative 1. Therefore, if you were to draw this line and if you were to draw this line, they would be perpendicular lines. Now let's talk about Cartesian coordinates in 2 dimensions. So most of this time, students tend to get confused with the basic thing of how do you plot a point. So remember, the first point you plot is x, then followed by the y point. It's like the alphabet. X comes before y. So if you were to point, if you have to read this particular point here, this will be the point 5, negative 6. This here is the x value and that there is the y value. So you must make sure then as far as entering or plotting of points that you do not swap points around, because if you swap them around you will tend to make mistakes. So let's have a look at a few. So I have a grid here and I have a grid here with a few points plotted. And I'm not going to do all of them. I'm just going to do a few. So I'm going to write down the coordinates of A, D, that is A here, and D here, G, F, and H. So when you look at A, obviously you go 4 across to the left. So that's going to be negative 4 for X first. And obviously down negative 3. So the point here is negative 3, negative 4, negative 3. This is the point A. And it's in the third quadrant. Remember, when it comes to quadrant, we start with the first quadrant and the second quadrant, third quadrant, and the fourth quadrant. Maybe something also important that maybe I should mention, that in the first quadrant, x values are positive, y values are also positive. So as you can see, if you look at any particular point, all the values will be positive. If I come to the second quadrant, the values of x will be negative. So I have got negative x values, but the values of y will still be positive. So maybe if I do the third quadrant, so this is the first quadrant here, and here this is the second quadrant, very important that we need to be able to identify, and here is the third quadrant, and everything in the third quadrant is negative. X values are negative, as well as the y values will be negative. And here in the fourth quadrant, what we'll realize is that the x values are positive. However, now the y values are negative. So let's look at D. And when you look at D, you will realize that the point D obviously is negative 3 and across and up by 1. So that is the value of D. Do not swap them around, because the moment you swap them around, you're talking about a total different point altogether. Then G will be 2, 3. And F will be 4, negative 3. And lastly, H will be 4 across and 1 up, and it's 4, 1. So you can do the other ones. It's quite straightforward. The only important thing you should never forget is do not switch around the points. Now let's talk about plotting. So I'm going to bring back the grid here. So I am going to plot and label. Okay, that means I have a point A. The A point, the origin is 0, 0. That's the origin. All right. So if I plot it, you can see I just plot it right there. Let me bring in another point B, which is negative 3, 3. So that means negative 3, 3. So I expect B to be there. Okay, you see, I plot the point and I then label it B. The same if I plot point C. C is 4, 5. So I expect it to be right up there. And you can see it's 4 for X and 5 for Y. Label the point and plot it. Okay, and then the point 0, negative 4. Now this particular point, the X value is negative. And here you must be careful. And on which line is the X value negative? It's on the Y axis itself. So what we realize is that this particular point here is on the y-axis. So when x is 0, then the points are going to be on the y-axis. All right. So you can use a little cross like I do here, or a little dot, but don't make it too thick, otherwise it becomes a circle and it becomes a little bit messy. Let me bring in another point, 3, 0, point E. So this point here has no Y reading, but it has an X reading. So I expect that point to be exactly on the X axis this time around. The next thing is drawing a straight line. Now, before I do that, I have a few teasers that I want to ask. How many points do you need to draw a straight line? I tend to ask this question quite a lot to the students. Have you figured it out yet? Well, let me bring in 2 points and you realize that, well, you have 2 points, you can draw a straight line. So the answer is you only need 2 points to draw a straight line. This comes really handy, especially when it comes to table drawing and stuff like that, or to completing a table. So let me ask the question, same question, just switch it around. What is the shortest distance between 2 points? So between this point and that point, what is the shortest distance? You have to go something like this, and then you go up like that. You realize that it is simply just a straight line. So this is very interesting. So the way we draw a straight line, we can use a first method of table, which is something that the lower grades have to know. You have to construct a table, find the coordinate points and plot the points. So let me bring in an example here. So we're going to draw the graph of y equals 2x plus 4 for values of x between -3 and 0. So what it means is we're going to bring in a 2-step solutions. We're going to construct a table, and then we're going to choose the values, a few values of -3 to 0. So in our table, for example, so I'm going to pick my table, the values of x is -3, -2, -1, and 0. Now I'm going to find the corresponding values for y. So let me take 1, for example. If I take x to be -3, so I take my equation, all right, as my equation is here, this particular equation, and when I insert -3 for x everywhere, I'll eventually end up with -2 as an answer, and then I will simply insert that -2, and then I'll go back. You can use your calculator, in fact, for this, or you can work it out. And now you're going to take the next value of x, which is -2. While if you insert it in there, you are eventually going to end up with 0. Taking x to be -1 in the same equation gives you 2. And obviously, if x is 0, you get 4. So now I have my points, or I have my table is complete. So what I'm going to do is I'm going to write these points now as coordinates. So this is going to be the point -3, -2. This is the point -2, 0. This is the point -1, 2. And this is the point 0, 4. So now what I'm left with is I have to plot these points. Remember, you know how to plot. And then I'm going to simply draw a straight line. You must plot them all. Although you only need 2 points to draw a line, you have to plot them all if they give you the table and they ask you to complete, and then you must plot all those points because you're going to lose marks. So let me just bring my points back again from the previous slide. So these are the points, and I'm going to plot these particular points here, plot all of them. Then I'm going to draw a straight line through the points, and then I check your calculations. If you are missing 1 point, it could be that 1 point is not collinear, it's not on a straight line. Then it means you have made a mistake, and then you have to refer back. So let's plot the point, for example, -3, -2. Then the point -2, 0. Then the point -1, 2. Then the point 0, 4. Can you see that they are already lined up in a straight line? They are all collinear. So if I bring that line, can you see the line passes through all the points? Although you only need 2 points, you have to plot them all, otherwise you're going to lose marks. And this is how you use a table method to draw a straight line. So there is another method which is called the dual intercept method. This is when you make x to be 0 and y to be 0. So what we're going to do is we're going to find the coordinates. We do substitution. The substitution we do, in order for us to find where the straight line meets the x-axis, we're going to make y 0 in our equation. If we want to know where the line meets the y-axis, we're going to make x equals to 0. So let's take an example. So we are supposed to draw the line y equals to 2x plus 4, previous one. But here we're not using the table method. So what I do is I am going to find where does the line cut the x-axis. So in order for me to find where it cuts the x-axis, I'm going to make y 0. And I solve this particular equation. So now I have a point where x is negative 2, y is 0. Then I'm going to do the same for the y-axis to find where it cuts the y-axis. I make x 0. So I take my equation and I make x to be 0. So now I have the point 0, 4, essentially giving you 2 points to draw that straight line. So if I was to bring back and I plot, the point negative 2, 0 is here. The point 0, 4, I expect it to be all the way up there. And when I join them, I'm going to get my particular line. Sometimes, and this is important, that students tend to, if they are asked to find the gradient, that they don't use the formula. Remember, the formula to calculate the gradient again is delta y over delta x. Now, this particular formula allows you to find the gradient, whether it's positive or negative. But suppose, and I'm just twisting things around, suppose this is what you have, and they ask you to find the gradient. Now, the gradient is that distance there, which in this particular case is just 4 units, divided by this particular distance here, which is 2 units. Can you see that? But the gradient, therefore, is going to be 4 divided by 2, okay, equals to 2. And you can see that that is the gradient right there. So you can use a grid if you are asked a question to calculate the gradient. But when you count the distances, you must be careful. You need to know how the line slopes, because the slope of a line will tell you whether the gradient is negative or positive. And I will do that towards the end, and you will see what I mean by that. So let's bring in something else a bit. So what we're going to do here is I'm going to do another example. And I'm going to say, let's draw the line 6x plus 4y equals to 12. So what we do is I am going to make the value, the x-axis. I want to find out where does the line cut the x-axis by making y to be 0. And when I make y 0 and I handle the equation, I'm left with x is equal to 2. So this particular point 2, 0, I will plot. Now, if I want to find out where the graph cuts the y-axis, then I take my equation and I make x to be 0. And if I do that, I have this point here. And quite simply, you've seen I have already plotted that point. So I just need to plot the other one as well. So when I plot the 2 points, I can now join the points together by drawing a line through. Please don't stop at the particular points. Go through, because a line is never ending. So that is how you do that particular question. Another thing I want to bring in is, how do you draw a graph and solve the equation graphically? Okay, so we are going to look at another equation, so which means we're going to solve them at the same time. So we have got 2 equations here. The equation is x plus 3y is equal to negative 6. Another equation is x minus y is equal to 2. So when I was doing the one in blue is the x plus y plus 3y is equal to negative 6, I end up with 2 points here. In this particular point, if I make y to be 0, I find that x is negative 6. And here's one here, if I make x to be 0, I find that y is negative 2. So I'm going to plot this similar like what I did before, but let's do the other one, y minus x is equal to 0. So again, if I make y to be 0, I realize that x is 2. And when I make x to be 0, I realize that y is negative 2. You can see negative 0, negative 2 is already common. So let's take these points, and so if you plot those points, you will see that I have done it here. All right, these are the points. This is the line x plus 3y is equal to negative 6, and this is the line x minus y is equal to 2. And what you realize is that where the lines are meeting, where they intersect, that is where the solution is to the equation, which is 0, negative 2. The next thing that I want to bring in is writing the straight line in standard form, in gradient intercept form. So sometimes they give you an equation and they ask you to write this equation in the form y equals to mx plus c. And then they might also ask you on top of that to write down what is the gradient and what is the y-intercept. So let's take this equation. So the equation is 2y equals 2y minus 3x plus 4 equals to 0. So what I did is I took the 3. But you see that I'm not putting the 3x behind the 4. I want it to be in front because it's representing the gradient. And then I divide by 2. And when I divide by 2, I realize the gradient here is negative. It's 3 over 2 or 1.5. But remember I said we would like to work with fractions because a fraction tells you the rise and the run. Delta y over delta x, and obviously the negative 2 is going to be our y-intercept. Another example here is 6 minus x plus 3y is equal to 0. Again, we're supposed to write it in standard form. So when we do in standard form, obviously I will get rid of that 6 by subtracting both sides. Then I add x. Can you see this? X here is being added, so it's now positive. I put it in front here. And what is left is for me to divide by 3. So what I see is that the gradient is 1 over 3 and the y-intercept also is equal to negative 2. Just one little point that I need to talk about this gradient. This gradient can be written as x over 3. And you should very much be careful that you do not think that the gradient there is just 3. There is the coefficient, but the whole thing represents the gradient, okay? The whole fraction. So this whole 1 over 3 here is our fraction. So they can write it to you at times as x over 3. You can see something like that, and then you wonder what the gradient will be. Okay, this is why we tend to write the fraction first and leave it like that, and then just put the x next to the bar there. Don't put the x next to the 3 because then you will talking totally about something else. Let's look at another example. So what I have here is I have y equals to 2 plus x over 3. But remember now, this one is already in y equals 2. So the only thing that I need to bring is bring that one in front. I'm not taking it over the equal sign. I'm not subtracting. I'm just rewriting it. So the gradient is going to be what I just talked about previously. It's 1 over 3x plus 2. That 2 is positive. You don't change the sign because you're not subtracting it from both sides of the equation. So the gradient is 1 over 3 and the y-intercept, as you can see, it's positive 2. Let me bring in one more example. Again, this is similar like the other one. It's y equals to 5 minus 2x. It's already y equals 2. You just have to rewrite this, rearrange and put the negative 2x in front for the gradient, and the positive 5 is there. So suppose this was minus 5, then this would have been minus 5. So you can see from here the gradient is negative 2 and the y-intercept is 5. A fourth example perhaps is very interesting. You see that I have got y over 2 here. So objective is get rid by this division by multiplying both sides by 2. So what I do on one side, I do on the other side, and it is very important that you do introduce brackets here. And 2 into 3x is 6x, and 2 times 2 is 4. And now you can see the gradient is 6, and also the y-intercept is 4. Something that I need to point out a lot of times that students are doing. The gradient is the number in front of the variable. Do not write 6x as the gradient. The gradient is simply the number in front. It is not the letter itself. So do not get confused by that particular point. I see that mistake happening quite a lot. Right, let's bring in another very important thing, and that is how to draw horizontal and vertical lines. Lines like y equals to some number or x equals to some number. So I'm going to do first our vertical line. Suppose we have a line here, and this line, you can see it cuts the x-axis. So the equation of this line is nothing but x equals to negative 4. Bring in another one. You see this line cuts the x-axis at negative 3, and this line is x equals to negative 3. That's all. This one is interesting. It lands on the y-axis. So its equation is x equals to 0. So another way for the y-axis to be written is x equals to 0. And then this one cuts the x-axis at 4. And its equation therefore will be x equals to 4. So let's take away some key facts that we know. So we know that the lines, they cut the x-axis, as you can see. And the line x equals to 0, this green one here is also the y-axis. Very interesting. So these are vertical lines where x is equal to a number. The number can be positive or negative, as you could have seen here. So let's talk about horizontal lines. So let me bring my grid back here. And if I bring my grid back and I bring in lines like the blue one here, you can see that this line cuts the y-axis now at 4. So its equation is nothing but y equals to 4. If I bring a red one here, you'll see that this cuts the y-axis at 2. So its equation is y equals to 2. And the interesting line is this line here. As you can see, this yellow line is on top of the x-axis. So it is y equals to 0. And the nice thing about this particular line is that when you are doing things like, suppose you come and do things like transformation, and you are supposed to say what transformation is, took place at one particular case. You could say something has been reflected, as you can see, and maybe it's on the x-axis. Then you can say it has been reflected on the line y equals to 0 when you don't want to say it is the x-axis. So that is very interesting to note. So let me bring in another line here. So it's going to be the line y equals to -3. So horizontal lines are lines that are cutting at the y-axis. So it's like y equals to a positive number or y equals to some negative number, like in this particular instance here. And again, worth noting is that the line y equals to 0 is actually another way to say the x-axis. So let me bring in some key facts so that we can see what is it that we are remembering from our work here. So y equals to mx plus c, this is the exchange in y over the exchange in x, that is the gradient. Now when lines are sloping in this direction, as you can see, then the gradient of such lines are positive. Lines that are horizontal, their gradient is equal to 0. Lines that are going in the downwards direction like this, all right, their gradients will be negative. One of very important things. So these lines upwards, you can say uphill and downhill. All right, uphill gradient is positive. When you are steady here, the gradient is 0, and downhill like this again, the gradient is negative. But what about a vertical line? Now the gradient of a vertical line does not exist because remember how we calculate gradient. Gradient is calculated by taking two y values, subtract from each other, get some number. When you take two x values, subtract from each other, the thing with a vertical line, it's going to have the same x value, all right, the same x value. And when you subtract, you get 0, and division by 0 is not possible. Right, so that brings me to the end of this particular presentation. So if you need more information, again, you can access my Google Classrooms. I have the codes here, the work that I'm giving to my students. I'm also going to upload material that you can actually download and work through your own. Remember that you can only master this if you are actually doing the work on your own. Thank you.